Hello children, welcome back to mathematics class. Today let us continue the lesson factors and multiples. We were studying about factors. Let us recall, what are factors? Factors of a number are those numbers which completely divides the number without leaving a remainder. For example, 3 is a factor of 12 because 3 completely divides 12 and does not leave any remainder. Let us continue with the lesson. Even numbers. I am sure you have learnt about even numbers in your lower grades. Let us recall. Numbers which are exactly divisible by 2 are even numbers. So, the numbers when you divide by 2, they leave 0 remainder. Such numbers are even numbers. Or to find out easily, even numbers end in 2, 4, 6, 8 or 0. What do you mean by that? The even numbers have 2, 4, 6, 8 or 0 in the units place. I repeat, the units place of even numbers will be 2 or 4 or 6 or 8 or a 0. For example, 2 is an even number, 24 is an even number, 1,33,678 is an even number. Observe children, the units place ends in 0, 2, 4, 6 or 8. In 24, the units place is 4. In 1,33,678, the units place is 8. I am sure you know what are even numbers now. Let us see what are odd numbers. Numbers which are not exactly divisible by 2 are odd numbers, which means that they leave a remainder when you divide the number by 2. In other words, odd numbers end in 1, 3, 5, 7 or 9. Examples 3, 37, 1259. If you can see, the units place end in odd numbers. Okay? Note, 0 is an even number. 0 is an even number. When you divide 0 by 2, you get a 0 remainder, or even the quotient is 0. We have a problem here. Which of the following numbers are even and which are odd? Let us check. 25, the units place is 5. So, 25 is an odd number. 32, 2, it ends in 2. So, 32 is an even number. Let us circle even numbers here. 44, 44 ends in 4. It is an even number. 49, it ends in 9. So, 49 is odd. 64, 64 is, yes, it is an even number. So, let me circle it. 65, it is an odd number. 377 is an odd number. 181 is an odd number. 292, yes, it is an even number. Let us circle it. 499, yes, it is an odd number. 1041, it is an odd number. 90,926, it ends in 6, so it has to be an even number. Let me circle it. Now shall we list the numbers? Even numbers are 32, 44, 64, 292, 90,926. Odd numbers are 25, 49, 65, 377, 181, 499 and 1041. Okay, I am sure now you are clear with even numbers and odd numbers. Note, even plus even is equal to even. It says that even numbers, when you add with even numbers, you get an even number. When you add two even numbers, you get an even number. Odd plus odd is even. When you add two odd numbers, you get the sum as even number. Odd plus even is equal to odd. Whenever you add odd number and the other number is an even number, then the result will always be an odd number. Okay, let us see some of the examples. 3 plus 5, odd plus odd, it has to be an even number. 8 is an even number. 4 plus 6 is 10, even plus even is even. 4 plus 9 is 13, even number plus odd number gives you a odd number. Clear, children? Without adding, tell whether the sum will be even or odd. Now we already know what happens when you add even numbers and odd numbers, or even numbers with even numbers, or odd numbers with odd numbers. With that knowledge, let us answer this question. 44 plus 86, two even numbers are added, so the sum has to be, yes, correct, even. Okay. Odd number plus even number, 43 is an odd number, 78 is an even number. So odd number plus even number should always give you an, yes, odd number. 123 plus 345, both are odd numbers. So when you add, you have to get an even number. Clear, children? Next, divisibility test. What is this divisibility test? When you see a number, you can check whether it is divisible by another number even before dividing the number. So such tests are called divisibility tests. Just looking at the number, you can check whether they are divisible by another number or not. Okay, let us see the divisibility tests. The first one is divisibility by 2. Okay, what does it say? If the units digit of the number is divisible by 2, then the number is divisible by 2. Let me repeat it for you. If the units digit of the number is divisible by 2, then the number is divisible by 2. Correct? What does it say? If the units place is divisible by 2, which means they are even numbers. So all even numbers are divisible by 2. If you find any even number, then it has to be divisible by 2. All odd numbers are not divisible by 2. If the units digit of the number is 0, 2, 4, 6 or 8, then the number is divisible by 2. In other words, or in simple words, you can say that the even numbers are divisible by 2. For example, 120, it is an even number. It is completely divisible by 2. 482, even number. 1384, it is even number. 2,62,388, this is also an even number. So these are the numbers which are exactly divisible by 2. Even before I divide them, I can tell that they are divisible by 2 because they are even numbers. That is the divisibility test by 2. Let us go to the next one, divisibility by 3. How do we do that? How do we check whether a number is divisible by 3? If the sum of the digits of the number is divisible by 3, then the number is divisible by 3. What does the statement say? If the sum of the digits of the number, if you add up all the digits of that number, and if the sum is divisible by 3, then the number is divisible by 3. Let us check. 36. 36. If I add 3 plus 6, I get 9. What did I do? I added up the digits of the number 36. And what did I get? I get 9. Since 9 is divisible by 3, 36 is also divisible by 3. Is it clear, children? When you add up all the digits of the number, the total or the sum will be divisible by 3, then the number is divisible by 3. Next one, divisibility by 4. How to check numbers whether they are divisible by 4? A number is divisible by 4 if the number formed by its last 2 digits is divisible by 4. What does it mean? The last 2 digits, that is the tens place and the units place, together are the 2 digits of the number. If that number is divisible by 4, then the whole number has to be divisible by 4. Let us see an example. 4,20,528. Okay, this is a big number. Just looking at it, I can tell that it is divisible by 4 because the last 2 digits, that is 28, is also divisible by 4. Since 28 is divisible by 4, 4,20,528 is also divisible by 4. Is it clear, children? Divisibility test by 5. If a number ends in 0 or 5, then the number is divisible by 5. This is very easy. If the end, that is the units place of a number, is either 0 or 5, then the whole number is divisible by 5. For example, 57,680, it ends in 0, so it has to be divisible by 5. 55,865, it ends in 5, so it has to be divisible by 5. The next one, divisibility by 9. If the sum of the digits of the number is divisible by 9, then the number is divisible by 9. This is same as divisibility by 3. If you add up all the digits of the number and the sum is divisible by 9, then the whole number is divisible by 9. Example, 84,348. Let us add the digits. 8 plus 4 plus 3 plus 4 plus 8. I have written all the digits of that number. If I add it up, I get 27. Since 27 is divisible by 9, the number 84,348 is also divisible by 9. Okay? I hope this is clear. Next is divisibility by 10. This is very easy. If the number ends in 0, then the number is divisible by 10. Example, 1,25,840. It ends in 0, so it has to be divisible by 10. 10 is divisible by 10. 340 ends in 0. Correct? 20,000. This number also ends in 0, so it has to be divisible by 10. Okay? Clear? Let us see some problems. Is 53,702 divisible by 4? How do you know that? The last 2 digits of the number should be divisible by 4. And which are the last 2 digits? That is 0 and 2. 0, 2, or in other words it is 2. 2 is not divisible by 4. Therefore, 53,702 is also not divisible by 4. Okay? Is 99,812 divisible by 4? What are the last 2 digits of the number? Yes, 12. 12 is divisible by 4, isn't it? 4 3s are 12. So 12 is divisible by 4. That is the reason 99,812 is also divisible by 4. Remember, children, when you are checking divisibility test, we know that 4 is a factor of, 4 is a factor of 99,812. When a number is dividing another number completely, that number is its factor. Okay? Since 12 is divisible by 4, 99,812 is also divisible by 4. Okay? Let us go to the next one. Is 53,702 divisible by 2? This is very simple. Since it is an even number, it is divisible. So let me write Yes, it is divisible. Okay. Next one. Is 99,811 divisible by 2? No, because it is an odd number. It ends in 1. The units place of this number is 1. Hence, it is not divisible by 2. So, I write no. Clear? Let us go to the next one. Is 2375 divisible by 5? What is the divisibility test for 5? The number should end in 0 or 5. So, here 2375 ends in 5. So, the number is divisible by 5. Clear? Next one. Is 98,762 divisible by 5? What is the last digit of the number? Yes, 2. Since it is 2, this cannot be divided by 5. So, 98,762 is not divisible by 5. Clear? Let us go to the next one. Is 13,059 divisible by 9? What is the divisibility test for 9? Yes, we add up all the digits of the number. So, here we add 1 plus 3 plus 0 plus 5 plus 9. What have I done? I have written all the digits. I am going to add these digits and I get 18. Is 18 divisible by 9? Yes, 9 twos are 18. So, the entire number has to be divisible by 9. Since 18 is divisible by 9, 13,059 is also divisible by 9. Clear, children? Next problem. Is 343 divisible by 9? What do? We add up the digits. Yes, 3 plus 4 plus 3 is equal to 10. Is 10 divisible by 9? No. 9 ones are 9, 9 twos are 18, 10 falls in between. So, it is not divisible by 9. So, 343 is not divisible by 9. Is this clear, children? Let us move on to the next one. Is 7,143 divisible by 3? We add up the digits. This is the divisibility test for 3. 7 plus 1 plus 4 plus 3. All the digits has to be added up and we get 15. Is 15 divisible by 3? Yes, 15 is divisible by 3. 5 threes are 15 or 3 fives are 15. Since 15 is divisible by 3, 7,143 is also divisible by 3. Clear, children? We will do one more problem. Is 2,375 divisible by 3? Let us add up the digits. 2 plus 3 plus 7 plus 5 will give you 17. 17 is not divisible by 3. Therefore, 2,375 is not divisible by 3. Okay. Is 37,825 divisible by 10? This is very easy one. The last digit has to be 0, but here it is 5. So, 37,825 is not divisible by 10. Next one. Is 98,760 divisible by 10? Yes, because the last digit is a 0. That is the reason 98,760 is divisible by 10. Let us continue. Prime numbers and composite numbers. Very important concept, children. Prime numbers and composite numbers. What are prime numbers? What are composite numbers? Let us see. Prime numbers. A number greater than 1 is a prime number if it has only two factors, that is 1 and itself. Let me read it again for you. A number greater than 1 is a prime number if it has only two factors, 1 and itself. What does it say? A number is called a prime number. It has to be greater than 1, like 2, 3 and so on. So, the numbers greater than 1 are prime numbers when it has only two factors, that is 1 and the number itself. For example, 2, 7, 29. For example, 2. What are the factors of 2? 1 and 2. So it has only two factors, 1 and the number itself. So it has to be a prime number. Next is 7. What are the factors of 7? 1 and 7. No other factors. Therefore, it is a prime number. 29. 29, the factors are 1 and 29. No other factors for 29, isn't it? It is not divisible by numbers other than 1 and 29. That is the reason 29 is also a prime number. What are composite numbers then? The numbers which are not prime numbers are composite numbers. A number is a composite number if it has more than two factors. If it has more than two factors, then it becomes a composite number. For example, 22. 22 has factors like 1, 2, 11, 22 itself, correct? So it has more than two factors, it has to be a composite number, it is not a prime number. 32. 32 also has factors like 1, 2, 32, 16, correct? These are the factors of 32. So 32 is not a prime number. Similarly, we have 72 and 121. These are not prime numbers. They are called as composite numbers because they have many factors, not just two factors. 1. What about 1? We know that numbers greater than 1 are prime numbers with two factors. What about 1? 1 is neither prime nor composite number. Okay, 1 is neither prime nor a composite number. It is not a prime number, it is not a composite number. Is 15 a prime number? How do we know whether it is a prime number or not? Yes, we find its factors. So what are the factors of 15? We have 1 and 15, correct? What about 2? Is it divisible by 2? No. 3? Yes. 3 5s are 15. 4, is it divisible by 4? No. 5? Yes. 5 3s are. So we have covered all the factors. It is having more than two factors. So 15 is not a prime number. Okay. Let us go to the next one. Is 29 a prime number? Let us write the factors of 29. It is 1 and 29. 1 29 times is 29. Any other factors for 29? 2, it is not divisible. 3, no. 4, no. You know the divisibility tests now. So you can easily look at the number and check whether it is divisible by the numbers. So here we have no other factors. That is the reason 29 is a prime number. Okay, it has only two factors, 1 and 29. Clear, children? Let us go to the next one. Write down all prime numbers less than 30. Let us write the numbers 1 to 29 because less than 30, so I am not writing 30. Let us go on circling the numbers which are prime. Let us start with 1. 1 is neither prime nor a composite number, so we leave 1. 2. Yes, 2 has only two factors, 1 and 2. So 2 is a prime number. 3, yes, 1 and 3. Any other factors for 3? No. So 3 is a prime number. 4 is an even number, so it has to be divisible by 2. So it cannot be a prime number. Remember one thing, children, even numbers cannot be prime numbers. The only even number which is prime is 2. Other than 2, no other even numbers can be prime because they are always divisible by 2. So more than 2 factors will be there. That is the reason even numbers are not prime numbers. Only 2 is a prime number which is even. Clear? Now 5. 5 has only 2 factors, 1 and 5. No other numbers. It has to be a prime number. 6 is divisible by 3, so it cannot be a prime number. 7, yes, it is a prime number. 8 is divisible by 4 and also 2, and moreover it is an even number, it cannot be a prime number. Next is 9, 9 is divisible by 3, so it is not a prime number. 10 is divisible by 10, 5, so more than 2 factors, it cannot be a prime number. Coming to 11, 11, yes, 11 is a prime number, let us circle it. 12, 12 is even, so it cannot be prime number. 13, yes, 13 is not divisible by any other number other than 1 and 13, it has to be a prime number. 14, not a prime number. 15 is divisible by 3, 5, so it cannot be prime number. 16 is even number, cannot be a prime number. 17, 17 is a prime number, other than 1 and 17 it is not divisible by any other number. 18 is even, cannot be a prime number. 19 is a prime number, let me circle it. 20 is not, because it has the factors 1, 2, 10, 5 and others. 21 is not a prime number, it is divisible by 7, it is divisible by 3, correct? 22 is even number. 23 is a prime number, it is divisible by 1 and 23, no other factors. 24 is even number, it cannot be a prime number. 25 is divisible by 5, cannot be a prime number. 26 is divisible by 2, even number, cannot be a prime number. 27 is divisible by 9, it is divisible by 3, correct? Not a prime number. 28 is even number, it cannot be a prime number. And finally we have 29, it is a prime number. So let us list all the prime numbers. The prime numbers below 30 are 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. Clear, children? Write down all the composite numbers between 20 and 30. 21 to 29, correct? Numbers between 20 and 30. Now let us check the composite numbers. 21, is it a prime number? No, 21 is divisible by 7, so it has to be a composite number, it has many factors. 22 is even number, it has to be a composite number because it is divisible by 2. 23, it is a prime number. 24 is a composite number. 25 is divisible by 5, it is a composite number. 26 is even number, so it has to be a composite number. 27 is divisible by 9, it has to be a composite number. Then 28 is even number, it has to be a composite number. 29 is a prime number. So the composite numbers between 20 and 30 are 21, 22, 24, 25, 26, 27 and 28. Clear? The remaining part of the lesson, let us continue in the next class, children. I will be sending some problems for you to work out in your notebook. Until I come back with the next video, take care, children. Thank you.